This problem is assessing basically one idea, and that is the idea that the only direction that really matters when it comes to work is the parallel direction. In other words, if an object is displaced this direction, so this is its displacement, the only forces that matter, or components of forces, possibly, are the ones that are either exactly parallel to it with it, or parallel, of course, but against it. Those are the only forces that can do work. As an example here, this one, I don't care how hard you push down on that, you are doing no work because your force is perpendicular to the displacement. All right, moving from here to here, that's the displacement vector. The force vector is certainly perpendicular. This is no work done. You can see this in the equation for work. If you look on the formula sheet, which I have here somewhere, I believe. Let's see. Look on the equation sheet, you'll see this. And in fact, let's bring that up. So right off your equation sheet, you will look at this. And when you see that, it will tell you, let me see, where's my bar here? Here we go. What it's trying to tell you is the only part of the force that matters is the force, the part of the force, or any forces that are parallel to the displacement. And the cosine takes care of that. Because you can do force times distance. Well, this, for example, here, there was a number to that force. It had a size, and here's a distance or displacement. But the angle between them is 90 degrees. And so this would be the cosine of 90, which is, in fact, of course, 0. If the angle is 0 degrees, or 180, think of the significance there. 0 degrees is in the same direction. I don't care what direction it is. There's two are in the same direction. That's a 0 degree angle between them. If two vectors are in the opposite direction, that's a 180. Both of those values are 1 or negative 1. 1 for cosine of 0 is 1, cosine of 180 is negative 1. And they will take care of, which, by the way, cosine of negative 1, that makes sense. Because if they're opposite, that's the definition of negative work. So the angle here will take, this cosine will take care of that if you actually read the angle carefully. So, back to our original problem. Pardon me while I adjust my screen. Screen adjusted, there we go. So, back to our original problem. Anything that has, let's see, well, anything that has perpendicular to the displacement, so this is 0 joules of work. This, like we said, F is 0 joules. So I'm going to just jot this down. I got F and D are both 0 joules of work. Now, this, the force is the same in every case. So here and here, the force is all parallel and it's the same. And since work is force times distance, I would assume that since you go double the distance here, you're going to have double the work. And in fact, if you want, let's see, they call it a force of F. So the work done here would be, for example, 5F. This would be 10F if you do the distance times the force. 0 here because we understand that the force has to be parallel. This is definitely negative work because it was this one. You've got a force to the left but a displacement to the right. So this would be negative 5F as the work done. And that leads us to this one. Now, this one, the only part of that force that matters is, and I'll do this one in red, we'll say, is its horizontal component. That's why, for example, we use cosine, because F, the horizontal component of this, of course, is F cosine of that angle, which is where that f and the cosine come from. So, by its nature, a component has to be smaller than the original. So, this is f cosine theta times 5. But by its nature, this has to be less than f. F cosine theta, as long as the f is the same number, so 10 times the cosine of any angle, really, is going to be less than just f. So I would put this, and by the way, it would still be positive because that component is with the displacement. So I would rank B as the first. I would rank, we'll make negative mean what it means. In other words, it's after 0. So I would then go, of course, A. And then I would do C, because it's definitely less than A, because it's just using the horizontal component. And it's the same F force, but you're only using part of it for C. And then I guess I would say D and F, 0 work, and then negative work done in the case of E. If you put the following, if you put B, A, and you put A and C together, and then did E, is that right? A and C together? No, not A and C together. If your answer was B, A, and E together, and then C, and then D and F, I could live with that because you're looking at E as just the magnitude, so to speak, of the work, and you're on the right track. So I wouldn't even necessarily call this wrong. I'm going to take it at its face value, that negative work is less than 0 work. That's probably fair enough. So yeah, this is all about, when you have an object, the force is perpendicular to the motion, you do no work. So for example, when you lift a box, you do work. Your force is this way, it moves that way. But when you carry the box around the room, as you're carrying it, your displacement may be to the left, but you're lifting or holding the box up. Those are perpendicular. So no matter how hard it is in the actual sense, carrying a heavy object around the room at constant velocity is no net work done by you. No, actually no work at all, let alone add them up together. All right, I think that's it.